This is the fifth episode of the series where we together implement library for runtime immutability checks called imcheck. So it's been a while since the last episode, and this one will be once again very short update on current changes without you seeing me all doing all these changes. Um, I actually work on it like few sessions. So here we have a little bit more changes that we usually have between episodes. But let's dive in. So we have a lot of new things. So first of all, we now support all types, including maps, channels, functions, all various type of pointers, and so on. We also now have exported constants for errors, so people can use errors is and other. So we basically wrap these errors with additional information, but people can use it to determine what exact error happened, and so on. We also support different options for checking immutability, so we can skip capturing of stack trace. So it kind of decreases debuggability but helps with performance. The same thing is with capturing string snapshots. Um, yeah, and we also don't allow inherently unsafe types by default. What I mean by inherently unsafe types, I mean, um, let me show it to you. I mean, basically, unsafe pointer, function, and channel. And why those types? I think you could have seen like comments on that regard in previous versions of the code. But basically, if we have unsafe pointer, we don't know what exact type is behind that. And basically, we can't know, there is no other possibility for us to know like how many bytes to use in a checksum that are hidden behind that pointer. And we don't know about anything about the structure of the data underneath that pointer, so there is no way for us to guarantee immutability. That's why we don't allow it by default, but you can still kind of opt in, and in that case we will basically just remember the actual pointer. So if it will change, we will detect the change of the pointer, but everything that is underneath that pointer we won't be able to check. For functions, it's kind of the same. Plus, functions can capture other state, um, or functions can capture state, and you can potentially mutate this state from the function. And there is no way for us to know what exact state you've captured and if you mutated it or not. At least not using reflection. So we basically treat it as unsafe type. And the same with channels. Basically, channels were created to be mutated from different coroutines. And there is no way for us to know if you added some messages to the channel and then these messages basically were consumed by other coroutine or anything like that. So what we could do, we could just check like the channel is closed or something like that. But I decided to just treat it as inherently unsafe type for us, because it's very weird if you want to check immutability of a channel. You can still kind of opt into it, but yeah, it's better to avoid such things by default. Um, yeah, everything else we kind of support. What else? By default, we also capture origin and we capture state, like string snapshot, but you can opt out of it. Um, As you can see right now, um, we did a little bit of a refactoring to make all the logic a little bit more concise. We can talk about it a little bit later. What else we have? Mm, and I think you can also notice that I think we can start to look into the code itself, not on a div. So if we take a look quickly at the switch that we had here, um, I decided this is the perfect kind of middle point where we can do some refactoring. Maybe this is not a final state and not the best possible way to do it, but I think it's kind of neat right now, and it's a lot easier to navigate and understand what is happening. So we now have this capture pointer function that can capture any type of a pointer basically. Um, yeah, and we don't need to understand. I actually figure out the way how to bypass the um, previous problem where we required to pass unsafe pointer plus reflect value. Now we just pass reflect value through the capture checksum uh, routine. So we can take a look at that as well. Um, what else? Yeah, and all this specific stuff, for example, capturing checksum of maps, capturing per field snapshot, I moved all this kind of specific logic to the specific types. I moved it to separate functions so you can kind of uh, jump into it and then read it carefully what is happening. I mean, for example, this one. You can read what is happening per specific type, basically. Mm, so it's a little bit easier to navigate, a little bit easier to understand what is actually happening. Um, yeah, and we were able to reuse most of the structures and or reuse these functions here and there where it's possible. Um, yeah, and I moved all this pointer handling and understanding at what exact pointer we are looking at and how to capture that pointer. We were able to move it into a um, separate function here as well. So you can take a look. Yeah. What else? The other thing, unfortunately, we should have get rid of skew library because when I introduced more and more tests for detection of pointer cycles, I figured out that actually the skew library has a lot of bugs related to this detection of cycles, and apparently there is even bug reports about for that library, but I don't think it is actually actively maintained right now. So there is no fixes, and yeah, I kind of looked few minutes if and attempted to fix on my own, but the build of this library is super old. Basically, I think it's for Go 11 or something like that, and it's a little bit hard to build it locally and run all the tests and so on and so forth. So I thought, okay, um, maybe we can like opt out of it for now, and either I'm going to fix the library and to like release it or fork it and fix, or I will write some kind of a replacement of it, maybe less sophisticated, but something that will work for now. And what we do right now is we basically get back to capturing just regular strings, I believe. Yeah, we just print f, or where it is. 1 second, where we create new value snapshot. Yeah. Right now, yeah, we just capture regular printf output. It's not as sophisticated. It won't be able to show everything, but this is kind of a intermediate step before we introduce any replacement for the previous library. Yeah, so I think that's it for now. We have options, and I think the next step for us will be start to write benchmarks and start to tackle, as soon as we have benchmarks, we can kind of start doing optimizations on this flow, because right now the library is actually functioning and I think it's in pretty good state, but the performance will be maybe not ideal. So as soon as we have benchmarks, we can start introduce performance optimizations little by little, tackling all these to-dos that we have here and there around pools of different types, reusage of value snapshots, pooling of map hashes, and so on and so on. By the way, I think we can remove that too. Yeah, and basically revisit all to-dos. That will be the thing that we will work next. Okay, thank you everyone for your attention, and yeah, please subscribe to the channel to get notifications about next episodes. Bye.